Hello and welcome. This is Emily Vasquez, Marketing Specialist at SkySwitch, and I just wanted to take a few minutes to talk to you about our platform, and more specifically, the redundancy of the platform. Our CTO, Blake McKeeby, created this great presentation that covers all of this. I'll first start by going over the physical architecture, starting zoomed in at the server level, and then we'll take steps each time as we zoom out. So we'll go server level, rack level, data center level, and then the geodiverse level. And then after talking about the physical architecture, we'll transition to the software architecture that's built on top of it. So at the server level, all the servers have redundant power supplies, and that's so if an upstream PDU fails, the server won't lose power. The servers have multiple NICs connecting to the diverse upstream switches using LACP. So if a portal in the NIC goes bad, or a portal in the switch, or if a cable goes bad, the server won't lose IP connectivity. And then for certain roles in the network, like for the PBX, we have servers configured with Linux HA. So if RAM goes bad or a processor goes bad and the server fails, the virtual IP will swing over to the standby server and assume responsibility for the service. So that's redundancy at the server layer. Zooming out a little bit at the rack layer, we have redundant power feeds and PDUs. So again, if a PDU fails or if the upstream circuit or equipment connecting to the far side of the power circuit fails, we won't lose power to the rack. And then we have redundant IP circuits, fiber connections to the rack configured with HSRP. So if one of those circuits fails or equipment on either side fails, failover happens in sub-seconds. And so that's the server and the rack level. Then at the data center level, the data centers we have picked have diverse powers. So they have at least 2 utility feeds, and that's important because if a car runs into a telephone pole right outside the data center, you don't want that to affect or sever utility power to the colo. Now, in the event that the utility power is severed to the colo, all of our data centers have battery backups which provide power to the equipment and prevent it from restarting if the utility feed is cut. And then they have, assuming it's not just a brownout, they have generators that then automatically kick into the power in batteries, which in turn power the equipment in our racks. And then our data centers also have diverse IP connectivities. So again, just like on the power side, there's a diverse physical path for the IP connectivity. They're on a fiber ring, so if there's a fiber cut right outside the colo, that one fiber cut alone isn't going to sever IP connectivity to the facility. And then they are interconnected to multiple tier 1 providers. And that's important because increasingly these national and even global networks are managed by individuals or small groups of people at any one time. And increasingly we see instances where these relatively small numbers of people can have profound effects that cause outages on national or even global networks. So you have to diversify in the providers you interconnect with so you can mitigate that risk. So those are the things that go into each of our data centers. And I can tell you that if you're not familiar with the data center game, this is not true of all data centers. These are attributes that you have to search out and then make sure are regularly tested. And then we have 3 data centers. At the geo level, we have Secaucus, Dallas, and Las Vegas. And those data centers are across 2 providers for kind of the same reason that you would need multiple tier 1 providers for IP connectivity. The data centers, while they generally may have utilities and facilities around the country, they generally centralize their NOC. And so to mitigate against someone in their NOC to make a change which can negatively impact multiple facilities, we have multiple co-location providers. And then the reason we're in these locations is that they represent good coverage for the United States and are geographically diverse. So hurricanes can come and flood a city, county, or even a state and cause power outages and interrupt service in a region. So you really have to have diversity in terms of where you're operating out of, and we achieve that with these 3 colos. So that's the physical architecture, and next we'll talk about the software architecture and what's running on top of it. The first thing to know about our platform is any customer can register or use any of our nodes at any time. So we provision customers to have a primary and secondary, but really, even if a node is not a customer's primary or secondary node, in theory, they could just as easily use that node. There's nothing inherently preventing them from doing that. So first we'll talk about how that's possible and how we create a platform where any customer can use any node. Once that's established, it's pretty easy to explain how failover and redundancy happens from the customer or client perspective. So to talk about how provisioning happens in the network, we expose on the provisioning side to public interfaces, the public portal, and the public API. And any HTTP client can use either of these in any of the facilities. So a customer's browser or a reseller's browser may use the public portal, but the reseller could easily write a Python or shell script and make requests using curl to the public API to perform provisioning tasks. The unique thing of the public portal is really just a thin layer on top of the public API. The public API really just exclusively interacts with the public API. So right now we'll simulate what happens if a write comes into the Las Vegas portal or API, but you can imagine this would apply to any of the public portals or APIs. So when a write comes into the public portal, it's immediately submitted to the public API, which is obviously also available to resellers. They can circumvent the portal and write it directly to the API. From the public API, it sends this write to the messaging bus. And it's this messaging bus that's really responsible for distributing that write across the Geo platform. So when the write comes in, the messaging bus sends that write to all instances of the Geo API in that network. Then it's this Geo API that writes to its local database and to the PBX. So what we're able to achieve with this architecture is that this PBX, this database, has all the same information in it that this PBX and database and every PBX and database instance in the network has. So this is what allows any SIP client to register and utilize any node in the network. Failover at this point becomes pretty simple. So we just provision the SIP client using a DNS SRV record, which in our case informs the SIP client, whether it be a Polycom, Yealink, about its primary and secondary servers. And it's the SIP client's responsibility at that point to fail over when it feels it cannot connect to the primary server. So whether it registers to its primary PBX, if it doesn't receive a response after a configurable amount of time, then it knows based on this SRV record to contact its secondary server, and it will utilize the secondary server until the primary server is available again. So this is how it works at the high level. I know there were a lot of acronyms and this is relatively technical, and you may have not understood all of the details and intricacies, but I hope you can appreciate the roles that each of these pieces play in contributing to the redundancy of the platform. If you have any questions, feel free to reach out to support@skyswitch.com.